Law of sines is what we're going to look at today. And law of sines is, I need to condense my notes here. I haven't. Law of sines, in the law, when we use law of sines, it can be used for any triangle. It can be used for right triangles. But unlike regular trig, sine, cosine, and tangent, law of sines can be used for a triangle even if it's not a right triangle. So it's very useful because while there are a lot of things in life that end up being right triangles, not everything is. So it's used for a lot of situations. One quick note, when you see this triangle here, capital letters, there you go. Capital letters, those are angles. Lowercase, those are the sides. And the same letters should be across from each other. So like angle A right here is across from side A. And angle B right here is across from side B. And angle C right here is across from side C. That's important because some of the problems you'll see whenever we're doing this, they don't give a picture. They just say capital A equals 56 degrees and little a equals 12.2. So they don't give you a picture to draw, so you need to know that. The law of sines is sine of capital A over A equals sine of capital B over B equals sine of capital C over C. You technically do not have to memorize this because they give it to you on a formula sheet, which I will make a copy of for you sometime whenever I remember to do that. But kids never have a hard time remembering law of sines. There's 100 other things I wish they put on the formula sheet besides law of sines. In fact, a lot of students use law of sines instead of regular trig. That it's just they like it so much, or it's so easy for them to remember. So whenever we use law of sines, we're only going to use one part of this equation. We'll see that here in a second. So we must be careful. Back in Math 2, whenever you were doing congruent triangles, you had a lot of theorems that could prove triangles were congruent. You had side, angle, side. You had angle, side, angle. You had side, 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 and angle, angle, side. Right? You had a lot of those that you had. Which one do you remember was the one that could not prove triangles congruent? It was angle, side, side. We could not have angle, side, side, right? ASS was not a theorem that we could use. So the reason that we couldn't use that is because if you have an angle and two sides where the angle is not between the two sides, there's two different triangles that could be made out of those same conditions. So we have to be careful when we're doing this problem because if we're given an angle and two sides, it is possible that there's two different triangles we could be talking about there. So I'll show you whenever we get there what we've got to watch out for with that. We won't see it on this first one, so it won't really matter. Okay, so on this first one, I've got two angles and a side, so no need for me to worry at all about the angle side. So I'm going to set up this problem. So I need to find B, so I'm going to say sine of 68 degrees over B equals sine of 37 over 3. And this we'll definitely have to use our calculators for, so make sure you've got your calculator and make sure you have put your calculator in degree mode. So I changed mine to radian a minute ago for something else. So you must be in degree mode for this. So if you hit mode, it's that third line, you must be in degree mode. If you're not, you will miss the problem. It'll give you a crazy answer. Sometimes it'll give you crazy negative stuff that doesn't even make sense. Okay, so to solve this, we're trying to get b right here by itself. So I usually just tell students cross multiply. So you get b times sine of 37 equals 3 times sine of 68. And I could go ahead and type sine of 37 in my calculator. It is just a number. 3 sine 68, that's just a number. But I prefer to wait till the end to type it in, just so I don't have to write down or remember any of those decimals. So if I'm trying to get this b right here by itself, then I need to get rid of that sine 37. It is multiplied, so I'm going to divide by sine of 37. Do be careful whenever you type this in. You're going to do 3 sine of 68. You have to close that parentheses right there. And then you divide by sine of 37. Last parentheses doesn't matter as much. First one has to be closed. Or sometimes I get a little nervous doing it all together. If you do 3 sine 68, let me make sure I did it right. Divide. Divided by sine 37. Oh, yeah. No, they're the same. Okay, never mind. Okay, so you're okay. Sometimes whenever you do that division at the end, like if you have addition earlier in the problem, it won't do it correctly. You got to do piece by piece, but it does this fine here. So you got 4.622. So 4.622 is your answer. Okay, how many of you have never done this before until today? Okay, 3 or 4 of you. Okay. Students usually do fairly well on it. It's usually something they do not have too many problems with. Okay, so in triangle PQR, P is 28, Q is 22, measure of angle P is 120 degrees. So I'm going to draw myself a triangle for this. You don't necessarily have to, but I'm going to. I'm going to call this P right here because that's I'm going to make that my 120 degrees side. So if this is 120, side P has to be across from it. So that's my 28. And then the Q and R, it doesn't really matter. I'm going to put my Q right here and my R right here. So that means this side right here is 22. Now, for this one, I do have 2 sides. So if I highlight this here, I have 2 sides. And I have the angle over here, and that angle's not the one between them. So I do have, in this case, I do have angle side. So watch out. Okay, you could have what is called the ambiguous case. And I'll show you how to check for that here in a second. So just to start out, we're going to set up the problem like we did before. We do have an issue here, though. Do I know? Well, I'm looking for angle R. Do I know the side across from angle R? I do not. I cannot find angle R straight away. But if I find angle Q, angle R is going to be really easy to find. I can just do 180 minus 120 minus whatever I get for Q, and I'll get R, right? Because all the angles of a triangle have to add up to 180. So we're going to find Q first, and then we'll be able to find R. So we're going to set up, we're going to say sine of 120 over 28 equals sine of q over 22. So we're going to solve this one like we did the other. We're going to cross multiply, so I get 28 sine q equals 22 sine 120. Okay. I can divide both sides by 28. So sine of q will equal, now 22 sine 120 over 28, those are all numbers. I think I'm going to go ahead and get the decimal for that. So 22 sine 120 over 28. Okay, that's 0.6804, so 0.680. And keep that number in your calculator. I'm going to round it off to write it down, but keep that number in your calculator. So, how do I get rid of a sine? What? Okay, it's not called the negative sign, but you're on the right track. What's that called? It looks like this. A sine. It's like a sine to the negative 1. Anybody remember what that's called? What is it? Inverse sine. It's the inverse sine. So we're taking sine inverse of both sides. You cannot divide by sine, because sine is an operation. It is not a number. So if we do sine inverse of both sides, then we're going to do, you do second sine. It's going to bring up sine inverse. And then you can do, so that you don't have to round that answer off, do second 0. Oh, no, don't do that. Second negative. Not second 0, but second negative. And that'll put that answer in. And so I've got that Q equals 42.879 degrees. Okay, so right here we're going to have to check for the ambiguous case. Alright, so if you think of your unit circle, on that unit circle, let me just pull up the unit circle again. I should have kept it up. Okay, so on that unit circle, you'll notice that, for example, if I want a sine of 30 degrees, sine of 30 degrees is 1/2. Okay, you'll also notice that sine of 30 degrees is also 1/2 over here in the second quadrant. So while sine of 30 degrees equals 1/2, sine of 150 also equals 1/2. If I do sine of 60, I'm going to get square root of 3 pi over 2. You'll notice over here, 120 is also square root of 3 pi over 2. So when your calculator gives you this answer right here, it's only giving you one of the answers. So, like for example, it would give you the 30 degree answer, but it would not give you the 150 degree answer. The calculator can only give you one answer at a time. So with sine, we have to check for what's called the ambiguous case. So right here, we're going to have to stop. We're going to have to check for ambiguous case. And to do that, notice it was 30 and 150. If you add those together, you get 180. If it was 60 and 120. If you add those together, you get 180, right? So even though 42.879 is not on the unit circle, it's going to have that same property. So if we do 180 minus 42.879, that is going to give us that's going to give us 137. 137.121. Now it is possible that maybe Q could be 42.879 or 137.121. Okay, it's possible. So to check to see if that is the case, we're just going to take that 137.121 and we're going to put it in the triangle and see if it's possible. So is it possible for me to have a 120 degree angle and a 137 degree angle in the same triangle? No, those add up to way more than 180 degrees, right? So this one is not ambiguous. Ambiguous means that there could be two triangles. So kind of like you would use the word ambiguous just in real life to say that, like, if a situation is ambiguous, it's like hard to figure out, you don't have an exact answer. Ambiguous means that there's two triangles that would work here. So for this one, it's not, because 137.131 is not going to be an answer. We won't see an ambiguous today because we're about out of time, but tomorrow you will see an ambiguous case. So Q is 42.879. So hold on, stay with me for a minute. So to find R, because R is what we were looking for, we've got to do 180 minus 120 minus 42.879, because those three angles have to add up to 180. So if we do 60 minus 42.879, we are going to get 17.121 degrees, and that is our measure of angle R. There. Tomorrow we will see one where we do get an ambiguous case. So I want you to finish that unit circle worksheet if you did not get it finished in class, and I'm also going to give you just a couple, or just a few to look at for law of signs, and I will not give you any that are ambiguous cases tonight. So while I kind of want you to know how to check for that, if you didn't quite get that last part, we're going to do more with that tomorrow. So it is going to be on page 316, and I want you guys to do 316, 11 through 15. If you do not have a graphing calculator at home, let me show you this real quick. So if you do not have a graphing calculator at home, on Desmos, okay, on Desmos, if you go up here, so if you do not have a graphing calculator at home, pay attention to this. Do not come in here and tell me you couldn't finish it because you didn't have a calculator. If you go to functions, it's got sine inverse, cosine inverse, and tangent inverse there. So you could type in tangent inverse of 50. Or sine, oh, you can't type sine inverse of 50. You could do sine inverse of, let me go back there, of 0.42. And it'll give you the value there. You might have to change it to degrees, because right now mine's in radians. So to change it to degrees, you go over here to the wrench and change it to degrees here. Okay. Alright, so you got to finish that worksheet, and you need to do 11 through 15. Was there an extra worksheet? No, Trevin's the only one out. There was not. Yeah, if you are confused on your ambiguous case, just don't worry about it for tonight, and we'll just solve it. Oh. Oh, also, when it says solve the triangle, it wants you to find all the sides and angles. We didn't do that. Just find me the one that's missing. So if you find, like, the first one has angle A, angle C, and side A, so find side C. You don't have to find all of the parts. Just find the part that's missing. Because we haven't